give you a little background, for the last 10 years I've been deeply involved with the distribution transformer industry in the United States as a director of strategic sourcing for one of the major distribution transformer manufacturers. So what we want to talk about is all the new efficiency standards that are coming out, and we're going to concentrate primarily on distribution transformers, both liquid immersed and dry type, and what are their impacts going to be on the materials that go into them. Who would have thought the coal-fired power plants would be a thing of the past? In the United States, there are a lot of them up for sale. Most of the major utilities are going to shut down coal-fired, go to solar, go to wind, go to natural gas. Natural gas is a big changeover for the coal-fired plants right now, and even growing nuclear. Who would have thought that the United States would be exporting liquefied natural gas? And there's a company, a utility in the United States has just signed an agreement to export liquefied natural gas to England for England's power plants. And who would have foreseen 5 years ago the rapid growth in solar and wind that we're seeing in the last 2 years? And it's going to continue. Efficiency standards. We've got federal standards, we've got regional standards. In the United States, even some cities are trying to put in efficiency standards. We've got standards for solar power, we've got standards for power plants. But what I want to talk about today are efficiency standards around distribution transformers. We have a new standard coming out in the United States, effective January 1st, 2016. There's a review of the transformer standards in Japan, January 1st, 2014. And right now in Europe, the European Energy Strategy, which is supposed to be complete by 2020, is in the process of looking at what they want to do on the standards for efficiency on distribution transformers. Right now they're working on a lot of other things, but the transformer standard is coming. What are the common factors? Efficiencies in excess of 98.8%. And for liquid immersed, efficiencies in excess of 99%. All distribution transformers are included. It used to be that if you were doing them for a company building a plant and they wanted a transformer inside the plant, that didn't have to meet the standards. If they were special projects, they didn't have to meet the standards. Under the new Japanese rule and the new American rule, every transformer made must meet the standard. And better materials are going to be needed. That's what we're going to talk about today. The US standard, liquid immersed transformers have to decrease losses by another 8%. That will make the typical US distribution liquid immersed transformer at about 99.3% efficient. In the previous standard in the US, dry type transformers were not even talked about. In the new standard, medium and low voltage dry type transformers, single phase transformer was no change. And that's the smallest part of the dry type business. Three-phase transformers, low voltage transformers have to decrease losses by 18%, and medium voltage by 13%. Those are major changes in the dry type transformers. What does that mean? Liquid immersed, M3 electrical steel is the base. Anything below an M3 grade of steel will not be viable on liquid immersed. increased volume of grain-oriented. An 8% decrease in losses is about a 10% increase in the mass of the core, using M3 as the base. And an increased volume of conductor. With M3 as the base and an 8% decrease in losses, that means the coil assembly will go up by about 15%, and that's still assuming copper in the high voltage and aluminum in the low voltage. Dry type, three-phase, M6 becomes the base for grain-oriented. Today, on the dry types, even the three-phase, an M12 or an M15 is the common material. With the new standard, that's going to be M6. And the increase in volume, core increase weight, 20 to 25% increase in the core mass. 25% increase in the amount of conductor. So you're going to see dramatic increases in size. The medium voltage can still use an M12 as a base. The Japanese standard, the 2014 review, they're going to reduce the number of categories for transformers that they've had in the current standard. They have currently about 7 categories. They're going to reduce that to 2. They're going to have the 500 kVA and above and below 500 kVA. Loss reductions for liquid immersed transformers about an additional 10%. And the baseline for that is more strict than the US standard now, so that's going to be a very significant increase in losses for Japan. On their dry type, the loss reduction is about a 5% loss reduction. What does that mean? Core materials for Japan, high bead domain refined, 090 category, 085, 080s, and amorphous. And of course, they already use quite a bit of amorphous in Japan, but that is going to go up. And they are looking very much in Japan for an improved conductor. Something better than copper, some new type of conductor that will be economically feasible to be used. The European standards, the Energy Commission is working on those standards now. They're probably going to be finalized within the next 2 years. The final, like I say, the final transformer standard is in process. You might as well figure it's not going to be any better than the US standard, if not more strict than the US standard. Domain refined materials will be the basis for a new standard here in Europe. What's important to the customer? In the United States, we have the public utilities. In the rest of the world, it's government-owned utilities and growing more private. They're all looking for cost. What is the total cost of the transformer? Efficiency. I can tell you in the United States, now that the new standard's out, the public utilities will want transformers meeting that new standard today, not 2016. They will go through immediately wanting the new standard. Plus, they want it to meet their specifications, and in many cases, the standards that the utilities want are probably going to be stricter than what the 2016 standard calls for. The transformer manufacturer, what do they want? Availability of the correct materials, lowest cost design, and meeting customer specifications. And this gets to be a juggling act. between lowest cost design and the availability of material. It's what I call the Trinity. Grain-oriented electrical steel, magnet wire and conductor, and transformer oil. That's what you have to juggle in order to get the best design, lowest cost. Electrical steel, these are the major mills in the world that make grain-oriented electrical steel. For the new standards, and I'm sorry, Thyssen, I didn't have your new book, but you would stay up there and not go off. See, most of the mills disappear. There aren't a great many mills left that are capable of producing the domain-refined materials that a 2016 standard is going to need for the US and a 2014 standard is going to need for Japan. Breaking this down, here's the list of the companies. These companies are currently making the regular GO. If it's got a C, that means they're in normal production on the high B and HGO. And again, Thyssen, you're in those numbers now, which I didn't know from your old catalog. And then domain refined, the companies that are making that. So you see, as the new standards go, if the transformer companies are going to have to use a high B and a domain refined, your choices are getting less and less. So what does that do? Electrical steel, what are they going to be looking for? We're going to be looking for thicknesses in the 0.23 to 0.20 millimeter. Losses better than 1.86 kilograms at 60 hertz, 1.5 Tesla. Non-laser scribe for the US because we anneal the core. And amorphous. The 2010 standard in the United States, they projected amorphous to get to about 10% of the volume. It never happened. With the 2016 standard, amorphous is going to become more of a player in the US market. It's going to become more of a player than the rest of the world. It already is in Canada, Japan, India, China. We're going to see more of it now in the US. And it will be coming to Europe eventually. And the US transformer manufacturers are going to want either foil or cores. Most of them don't want to make their own cores. They want to buy cores if it's amorphous. Impact on electrical steel, like I said before, dry type, single phase, no change. There's going to be a push away from using non-grain oriented to using an M12 product as their base. Three phase, non-grain oriented in the United States is out. And pretty much in Japan it's out. The new base will be an M6 product. And a push toward M4, which is a major change on the dry type transformer. They go to an M4, they can keep the overall size of the transformer down. In the Trinity, electrical steel determines conductor. There's an old unwritten rule. When the price of copper is at least 2.5 times the price of aluminum, then it is worth it to the transformer manufacturer to look for better grain-oriented steels and use aluminum in both the high voltage and the low voltage. LME closed yesterday. Price of copper was 3.8 times the price of aluminum. So you know where the push is going to be. Use as much aluminum as you can. There was a speaker downstairs earlier today that was talking about an anodized aluminum strip that could be used in place of copper. People are looking at this. What's going to happen? Traditionally, copper high voltage, aluminum low voltage. We've seen a change in the United States to a growing increase in the amount of aluminum conductor being used, away from copper, being used in both low and high voltage. Last year, toward the end of 2012, there got to be a tightness in the market worldwide for aluminum bull rod that was of the correct quality to be drawn into magnet wire for transformers. And outside of a couple of areas of the world, particularly the Asian market, that tightness of the correct type of bull rod is still in effect today. And they project it will have impact through next year. So if we're going to be pushing more toward aluminum, there's the next key stone that's going to be hit. And then is there enough wire drawing capacity? Most plants that draw magnet wire on both aluminum and copper magnet wire on the same equipment. And everyone talks about magnet wire capacity in copper equivalent pounds. And that's fine, but it takes 3 times the time to draw a pound of aluminum that it does to draw a pound of copper. So if the switch continues from copper to aluminum, what happens to drawing capacity? It became very tight 2 years ago in the United States. It's going to get worse. And nobody wants to spend the money to put on additional drawing capacity right now, not knowing what's definitely going to happen, because it's expensive to put on additional drawing capacity. Conductor and steel determine transformer oil for a couple of reasons. We have the 3 basic types: a naphthenic, a paraffinic, or the bio oils, the FR3s of the world. Cooling capacity. If you use the M6 and you use copper for the high voltage and aluminum for the low voltage, you're going to be operating at higher temperatures than what we do today. If you operate at higher temperatures, then you're going to have, for pole mounted and for pads, a larger container, because you're going to have more oil to keep it cool. If you can go to some of the better electrical steels and use aluminum in both windings, or you go to amorphous and use aluminum in both windings, your operating temperature is lower. At that point, you can keep your transformer almost the same size, and you may not need to add additional oil. Higher operating temperatures. These two have a limit. This, 50% higher temperatures could be operated with. So is there a trade-off in the cost of the bio-oils versus the others to have the higher operating temperatures and not increase the total amount of oil you use? Or do you increase the amount of oil on the others and increase your tank size? Again, it goes back to what conductor are you going to use, and it goes back to what grain-oriented electrical steel or amorphous can you get. So you have to continually juggle these and the cost of all these. So electrical steel, conductor, and transformer oil are the Trinity. What's some of the projected impacts? As I talked earlier, electrical steel, 10 to 20% increase in demand. That's M6 and M3 are the 2 bases that are going to be the highest in demand. The transformer companies are going to want other electrical steels that are much lower in losses to come into the marketplace. Higher pressure on the high B and the domain refined materials. That's where the new market is. European domain refined has been primarily laser scribed. If they get down to the 085s and the 080s without laser scribing, then everywhere that they use wound cores, this will be a major advantage, a major increase in bound material available. Amorphous metal. You're going to see an increased demand in the US, and you're going to see an increased demand in the Japanese market in particular. We're already seeing increases in Canada, South America, Central America. Conductor, 15 to 25% increase in demand in both copper and aluminum, above what you're seeing today. The mix change, as better domain refined materials are available, the mix change will continue toward aluminum away from copper, unless somebody can bring the copper prices down. And I don't see that happening anytime soon. Continued pressure on magnet wire drawing capacity. Continued demand for the high quality copper and aluminum bull rod. As these demands go up, having the purity of the bull rod to be able to draw into the finer wires without massive defects is going to be critical. And the demand for a higher efficiency conductor. Somebody needs to come up with something that is better, other than silver and gold, which no one can afford, but there's a real demand out there right now for some type of better conductor, a refinement on copper and aluminum. Transformer oil. We have the possibility of the transformers running at higher temperatures, which is a benefit for the bio-oils. Larger tank size. There's continued environmental drive toward the bio-oils. One of the fallbacks to that is when we talk about hazmat spills, hazardous material spills, most regulations around the world today consider a bio-oil the same as a petroleum-based oil as far as being a hazardous material in a spill. If that changes around the world, the various countries regulate that bio-oil does not have to be treated as a hazardous material, then you're going to see a tremendous drive toward the bio-oils. But right now, they and the petroleum-based oil are treated exactly the same in the case of a spill. Cost. Higher material costs. The better grain-oriented costs more. Amorphous costs more. Bio-oils cost more. More material required and higher cost material. So there's going to be a continual push to juggle these three elements to come up with what is the lowest manufacturing cost and what is the lowest total cost to the utility. What are the options? Greater use of amorphous metal, and with it comes greater use of aluminum conductor. Using amorphous, there's a little increase in core size or coil size. Lower operating temperatures and no need for additional cooling fluid. With grain-oriented, it's an increased demand for the lower loss material, and if that can be achieved, then the increased demand for aluminum conductors.